All right, cool. So I think we are now streaming on YouTube. Um, so welcome YouTube if you're watching this later. What we're going to be using today for the Learn Cadence session is the Flow Playground. Now the link to that is play.flow.com. So play.flow.com, I'm just putting that in the chat here. It's just a really nice way to interact with the Flow blockchain on the web. So it's just a great like learning environment. So yeah, we're gonna be using that today. So what I'm gonna do today is I'm gonna go pretty quick. So if there are topics that you get confused on, just let me know in the chat here. But I am gonna go quick because there's a lot to cover and we only have one session to do it. Um, so yeah, let's just do this. Um, so in order to make a contract on the Flow blockchain, it's pretty simple. You just write pub contract, then the name of your contract. And I think what we're going to do today is maybe call our contract, um, let's just call it like test for now, because we don't really know what we're building yet, but let's just call it test. So right now we have a contract called test, and if we wanted to, we could just go ahead and deploy it. So if I click deploy, it's now deployed to the Flow Playground, and we officially have our own contract, right? Now let's say we want to add some state to this. Let's say we want to add like a variable called I don't know, greeting, and we want it to say hello to people, we can make a little, greeting variable here just by saying public greeting. This is the name of the variable, and then the type, which is a string. So we could also make this like an integer, or we could make it like an address, right? There's a lot of different types we can put here. We're just going to put string. Now, for any variable that we create, we have to also, inside of an init function, we have to initialize it. So let's just say self.greeting equals like hello, comma world, right? The most typical example, I guess, in the coding world. So what we've done is we've initialized a greeting variable, and when we deploy this contract, the init function will get run, and it's going to set greeting to hello world. But that's all this contract does, right? So it's pretty simple. So if we go ahead and deploy this, now it is deployed to a certain address, right? 0x01. And let's try and actually read this greeting inside of what we call a script. So a script is also, now this is unique to other contract languages in that um, when you write scripts or transactions, they're also in Cadence code, right? So it's not like in Solidity, if any of you have used Solidity before, where you kind of write the contract and then you just call into the contract using like JavaScript or whatever you use. Transactions and scripts are both in Cadence; they're just a separate layer from the contract. So the way that scripts work is you just put public function main, and actually the playground already pulls up a template for you. So you put public function main and then the return type. So in this case, what we're going to do is we want to read the greeting of the test contract that we just deployed. So we have to import this test contract. So let's go ahead and do that. If we import test from, and in our little console log here, it said we deployed the contract to 0x01. So we can import that right here, okay? And everything works fine. Now, if we want to return the greeting type, right? Let's say we want to return this variable. What should we make the return type of this function? Does anyone here know in the chat? String, exactly, right? So we just put a string here and we can return test.greeting. Now, usually it should pull it up, but I guess it's not. Return test.greeting. I guess it's not exactly sure why it's giving it. It's just Playground being stupid. But if we execute that, yeah. So if I just refresh the page and execute it, we can see that it returns hello world. So it works pretty well. Awesome. Sounds good, Nazir. Yeah, Playground always is stupid with me for some reason. I don't know. It just is so like when I start doing tutorials, it starts messing up. But okay, yeah. So there we go, right? So pretty simple. Now, let's say we want to make a function to actually change the greeting, right? So what we can do is we can make a function called change greeting. And inside of here, what we're going to do is pass in a variable called new greeting. And inside this function, we will just set self.greeting, which is this variable right here, equal to the new greeting. Okay. Now it's going to give us an error here. It says cannot assign to constant member greeting. Reason for that is because in Cadence, let is a constant, whereas var is just a normal variable. So if you don't want your variable to change, you should make it a constant with let. Otherwise, you should make it var. Okay. So if we go ahead and deploy this contract again, it's now deployed to 0x01. And just to confirm, we can run the script again to make sure it is hello world. Well, let's go ahead and change it inside of a transaction. So let's import test from the 0x01 account. And this is what a basic transaction looks like, right? It has the transaction keyword. It opens up these curly brackets and has prepare and execute here, right? So these two things here. Now, I'm not going to go over what these two mean yet, but I will during the session, so don't worry. But all you should know for now is that we're going to go ahead and use the execute section because the repair section is actually meant for something different. So let's go ahead and use execute. So what we want to do is say test.change greeting. Exactly, John Moran. So the script is to read from the contract, and the transaction is write to the contract or change it. So because we were just reading the greeting, we wanted a script. But in the transaction, we're going to actually change the data of the contract. So that's why we're going to call change greeting inside of there. So I think I have to refresh the playground again because it's being weird. But if I do test dot change, okay, so now if I refresh the page and do dot, it actually comes up with the correct thing here. So if I click change greeting, then we can pass in the new greeting. Okay. Now we could easily just put like, maybe we want to put like goodbye world, something different. But what's actually better is if instead we just make a new variable up on the transaction called new greeting, make it a string type, and now the playground will actually bring up like a little tab for us to type in um some, some new value here. So what we can do is inside the new greeting, we can type in, let's say goodbye, and it doesn't matter who we sign it with. We'll just do account one for now because better, and send it. And so hopefully we get no errors, right? So no errors just happened. So if we go back to the script to read it, then we should see that it now says goodbye world, right? So we were able to just change it. Are there any questions about what we've done so far, or maybe the differences between a transaction or script, or how we wrote a function? Any questions so far? See, John Ron is typing, so I'll wait just a. So what about if I need to read from another contract? Do I need to import it? How is it read from the? Yeah, so if you want to read from a contract, you have to import it, right? So the whole thing is there was a greeting variable inside the test contract that we deployed to account one. So inside our script, we had to import tests from account one in order to read test.greeting. And if you wanted to import, let's say there was another contract called John Moran from account three, then you could also read, maybe John Moran dot, let's say you had a variable called greeting also, or you had a variable called, I don't know, test, right? You can read it just like that, but you would have to import it. Yes, exactly. So in your, yeah, you could basically call whatever you defined in that contract. So for example, inside the contract two tab, let's say we have a contract here called John Moran, right? And we have this variable that, I don't know, you let's say you made it color, and it was a string. You would be able to read color inside here by just saying import John Moran from account two, and then you would say jamron.color, and this would give you the value of that um, variable. Hope that makes sense. Awesome. So the next thing we're going to cover is that we're actually gonna dive right into structs now. But I also do want to mention really quickly that um, remember that if again, if I am going too quickly, you can always use Cadence by example. There's a lot of like just really helpful um, things here. It's a great learning resource. I want to mention it. Okay, so let's say we want to have something more than just a string. Let's say we want to have like an array or a dictionary, right? How do we define those types of things? So let's actually just, sort of go back to our um let's get rid of these two things and this here. And we're going to talk about arrays now. So let's say we have an array called names, right? And this is an array of strings. This is how you define an array in Cadence. You put brackets around a type. So this is saying we want to have an array of string types. So we can say self.names equals empty array because we have to initialize it to something when we deploy the contract. Now, let's have a function called add name. And the name will be a string type. And inside this function, we can just say self.names dot append name, right? And so all this is going to do is just add a name to the names array. Now let's also say we wanted to have a variable called profiles. And inside of profiles, we're going to map an address to a name, or not a name, sorry, a string. And a name is not a type. And so what this is going to do is this is going to map an address. So, an address in smart contracts is something like 0x01, right? Or in the real world, it's more like this length or something. But in the playground, it's just like this. And we're going to map that to maybe like Jacob or something, right? So let's add another function here, maybe called, and I'm just doing this just to show you what arrays and dictionaries are like. Dictionary. We can say add profile, and we can say the address, and the name is a string, and we can just say self.profiles at the address name. And so this is how we work with dictionaries, right? We just say the profiles at the address key, right? Because address is the key, and then the string is the value. Self.profiles at address key equals name, which is string. And it's giving us an error because we haven't initialized our profile yet. All right, so let's say we deploy this contract. If we go to our script and try to read test.names, it's we're returning an array of strings. So it should be empty right now, right? Yep, totally empty. But if you go to a transaction and let's call this, I don't know, like a name, we can say test dot add name and pass in a name. And let's just say we add Jamaron, send it, go back to our script. We should see that if we execute now, that Jamaron is now in the array of names. And we can go ahead and add someone else too. That we want to add Nazir. Go back to our script, run the execute, and we see that both names are now in the array. Pretty cool. Yeah, so we did. So the whole reason that we're able to add a name to that Jamaron is because we added a function called add name. So inside of that contract, um, yeah, so we have this function here called add name. So we're calling this function. So if we didn't have this function here, we wouldn't be able to do that. Okay. So what if we wanted to maybe do a profile now, right? Because this requires an address and a name. So why don't we do this? Why don't we take the address of whoever signs this transaction and allow them to pass in a name and add a name to the dictionary. So let's do that. Let's get the address of signer, and this equals signer dot address. It's actually pretty simple, right? And then we want to get that to the execute phase. So what we're actually going to do is we're going to make a local variable above the prepare phase. This is what I do, and say let signer address, make it an address type, and then we can just say self dot signer address equals signer that address, and then inside test dot add profile, because the address we're going to pass in is self dot signer address, and the name is whatever name we pass in here, right? So if I pass in the name Jacob, which is me, and I select let's say I'm account 4 and I'm signing from account 4, I can send this, and now in the script, if we read test dot profiles, this should be a address string type, and if I execute, we see that it now is mapping address 4 to Jacob. Now, does anyone see any maybe like security issues with this? Like, I guess what I'm trying to ask is, could I set someone else's profile maybe? Because right now, when we call add profile, it is getting my address from this, signer object, and that is me who signed it. But the problem here is that I actually would be able to write my own transaction where I just set anyone's profile, right? Because, I could write my own transaction that basically just doesn't do any of this. I could even comment this out. And then inside the address field, I could just pass in like 1. And then all of a sudden now I'm setting the profile for account 1 here, right? So because transactions can be written by anybody, can't just do this type of security at the transaction level. And this is sort of a broader point that like you can't secure anything from transactions because like anyone can always write their own transaction if that makes sense. Exactly. Yes, that's also true that the functions are public. So if they're public, then anyone can call them, right? So anyone can add this profile. So we're gonna get into like how sort of access is Cadence. But this was the first like third of this workshop. This kind of concludes the like more beginner type stuff. So we're gonna get into struct soon. But any questions so far? All right, cool. How do we protect the function from the contract side? That's a good question. So what we could do is do something like um so the way that this works is public is obviously a public function, so this can be called from anywhere. There's a couple other access modifiers, we call them, that we can put here. We can put access contract. Now this means that this function can only be called within the contract, so we wouldn't be able to call it from the transaction anymore. We can also put access account. This is a bit more complicated, but this means that this function can only be called within other contracts in the same account. So in Cadence, you can deploy multiple contracts to one account. So this is saying that any contracts or this contract inside the same account can access it. And you can also say access self. Now, access self is the most strict, and this is saying that this can only be accessed within the current like context of where this is defined. So because this is defined at the contract level, it essentially acts the same as access contract. But like if we get into like structs in a sec here, if we got into like test struct and put this function inside a struct, then access self would only be accessible within the struct, so here, and not here. So how can we make users add a profile only with their address being used? That's a good question, and I'm gonna get into that later in the workshop. But the simple answer there is resources, and I'll show you later in the session how we can set a profile with only your address. Okay, so before we get to resources, we have to quickly cover structs. So we're gonna make a struct. Now, what a struct is I guess if you code it in other languages, essentially a struct is just a container of data. So we can make a struct called profile, and let's just make a profile have a name. Let's make it have a address, and let's also make it have a favorite number. So the person's favorite number. All right, so we can pass in the name, string, address, and fave number. Now, just like with contracts, how when the contract is deployed, the init function gets run. Well, when a struct is created, the init function gets run, right? So we have to set these values when the struct is created. Self.name, name, self.address equals address, self.favorite number. Okay. And structs are always public, so you can create structs wherever you want. So let's just make a little a state here that says profiles, and we're gonna map a address to a profile type. Now, because we have created our own struct, this essentially acts as a type now, right? So profile is its own type because we created it. And let's make a function called add profile, and we're gonna have to pass in a profile type. Okay. And then we'll say self.profiles at profile.address, the profile itself. So what we're going to say is we're going to pass in a profile type, and we're going to set inside this profiles dictionary, we're going to set the address of the profile.address, right? This value right here, equal to the profile itself. Yeah, BZ, I refuse to change that for now. What BC is talking about, by the way, is that so Cadence 1.0 is coming out in like a couple months, and public is no longer going to be used. It's going to be called access all, which I honestly hate because it's so verbose. Like you have to write so much. Actually, like access all is currently in the language. It's just that access all and pub um are like equivalent, but they're actually removing pub, so you have to use access all. I think is probably the best thing I've ever heard, but that's the point. Okay. So that's okay. So this is a function to add a profile, right? So let's go ahead and actually try this. So if we deploy and go to scripts, let's now try to execute. So this is a good question, right? So what is the type of the return now? Because it's an address to a profile type. A profile is just defined within this test contract, right? Um, so the way that we do this is you say test.profile. So that is the type of the profile struct. It's a test.profile because it was defined in that contract. And we can return. I think I have to refresh the page here. Uh, oh, I forgot to redeploy the contract. I think. Not sure what that. If we refresh again, yes. Okay, so now it returns empty dictionary, right? Cool. So if we go to transaction now, and we go to this little execute part, we can now try to say test.add profile, and we have to create a profile now, right? So we have to do that. So for now, what we're going to do is we're just going to keep using the signer's address, even though that is not secure. We know that now, but we're just going to keep using it. But we also need a name and a favorite number. and then we're going to pass that in. So we're going to say let profile equal a test.profile, and we can pass in some arguments here. So the name is name. I think we're passing in these right now. So the name, address, and the favorite number. The name is just the name that we pass in. Address is self.signer address, and the favorite number is the favorite number that we pass into the transaction. Okay. So if we go here, we can say the name. Let's just say OBO. And favorite number, OBO, what is your favorite number? 7. Boom. So we'll send this from account 2. Let's just say that you're account 2. So we'll send that and go to script. And if we execute, we should see that we now have some data in this dictionary, right? Account 2 is mapping to a profile type, right? Where the name is OBO, the address is 2, and the favorite number is 7. That's pretty awesome. So what if we want to make another script? Let's add another script here. And in this script, we don't want to read all the profiles. We just want to read one profile. So let's say in this script, we want to read one profile user, right? We're going to say address right here. And we're just going to return one test.profile, right? So what we're going to say is we don't want to return test.profiles. We want to return test.profiles at the address, right? Because the address is the key. Now, we're going to get a little error here. And the error is expected test.profile type, but got test.profile question mark. So what the question mark means in Cadence is that means an optional type. An optional type is essentially where it's either the type or nil, or I guess like null in other languages. So it's essentially telling us that, hey, you're expecting a test.profile, and you may get that, but you also might get null, and that's sort of a problem. So there's a couple ways to do this. We can either just what we call force unwrap it, which means we put this exclamation mark here, and that's saying, you know what, Cadence, like if it is null, then just abort the program and that's okay. But if it's not null, just give us the test.profile type. So let's just do that. So if we put in like 0x02 here, we will get a test.profile, which is right here, right? With the OBO, address 2, favorite number. But if we put in an address that doesn't have a profile yet, let's say like 0x04, and we execute, we're going to get an error, right? And it's going to say we aborted the program because we found nil when we were forcing an optional value, right? So we were trying to force an optional value here, but we found nil, and so we aborted the program for you. So that's what this does right here. But the best thing to do inside of a script is just to actually return the optional type. So that way if you were thinking about like building dApps or something, and you ran a script, you don't want your script to like panic and return an error. You want it to just return null and then be able to handle that in your dApp, right? So you just question mark, and now if we run this, instead it's just going to nil, right? So it's much better that way. And to be even more specific, let's say we just wanted to return the person's favorite number. Well, then we could just say, let profile equals test.profiles at address, and we're going to unwrap it. And then say profile.favorite number, and then we're just returning an int in that case, right? So if we wanted to favorite number 2, now we're getting 7, right? And if you actually, here's a trick: if you still wanted to return the optional int, like, because right now, again, if we put in like address 4, it's just gonna panic right now because of this operator. But we can actually remove this and just instead put a little question mark here and say profile question mark dot favorite number, and that's just saying, you know what, like if profile is nil, just don't do the rest of this. But if it's not, then just keep going. So we can execute again. We should get 7, but if we put 4 here, it's just going to give us nil. All right, so that is just a basic crash course on accessing values in dictionaries and what optional types mean, and also just generic structs. One thing I do want to show you, by the way, is that you can actually add functions to structs. Say we want to change the name, we can pass in a new name here and say self.name equals new name. Now remember, we have to make this a var because let is a constant. So you can actually add functions too. So let's say inside of this transaction, yeah. So you can add functions structs. So if we redeploy this, yeah. So what you can do is inside your transaction. Well, actually, you know what we'll first need to do? We should first find a way, and this is the next topic, is find a way to get references to certain things, right? Like, how do you get a reference to the profile? Because what we want to do is like if we were to do this, right? If we were to make a function called get profile and we were to pass in an address and return a test.pro and just return a profile type, what's going to happen is if we were self uh, profiles at the address, this is going to return a copy. So if we were to try to call the change name function on this copy that we get, it's not going to do anything. So we have to actually get a reference instead. So let's make a function called get profile reference. And we're going to return a reference to a profile. So the reference is denoted by the, what's this called? Ampersand? I think that's what it's called. Okay. So we're going to return a reference. Now the way that we do that is we say return. Oh, and by the way, in any getter functions like this, like I was saying in a script, you should never be force unwrapping in a getter because it's just not good practice. So you would want to return the optional type here. Just because, like, if people are calling into your contract, you don't want to be aborting the program if they pass in a key that doesn't exist. But that's just like best practice. So same here. We want to return an optional type if it. So what we can do is we can return a reference to self.profiles at address. However, this isn't going to work because when you get a reference to something, you always have to cast it. So you have to say as a reference to a profile optional type. And again, this casting is just specific to when you are adding like the ampersand, or sorry, when you're getting a reference to something, you have to always cast it. Okay, so this will actually give us a reference. Um, However, the problem with this is that, again, this is a public function, which that's not best practice, right? Like you shouldn't be able to, because like now that we define this function, anyone could technically call this function and just update anyone's profile, right? And that's not good, but just stick with me for now. So if we deploy this, let's say we now create a new profile, where the name is OBO and the favorite number is 7. We send it, right? And we go to the script, and we should see that that is now created right here. So the name is OBO. Well, let's say we run a transaction where we say we're going to actually add a transaction here, where we say for address, or for the address that we have right here, we want to get a reference. So let profile ref equals test dot. Did I deploy the contract? Test dot get profile. Oh, here we go. Profile ref self dot signer address, and then we're going to say profile ref dot change. The new name is name, right? And then we don't need a favorite number. Why is it? Oh, it's actually giving me this error because remember, this is an optional type. So the type that it's giving us right now is actually test.profile optional, right? I think. Oh, a reference to test.profile optional. So it actually is an optional type. So what we can do is we can unwrap it by putting the exclamation mark here, and that's saying, okay, now we're allowed to, because you can't call functions on an optional type. So even better, what we could do is just make it more clear. We could remove the optional type by putting the exclamation mark here, or a better trick actually in transactions, because transactions you should abort, right, if something isn't as expected. Instead of putting the force unwrap operator, we can instead put the panic operator like this, and that way we can actually put a message. We can say, oops, this profile does not exist. All right, and we can space it better. So this way, we no longer have the optional type, and we're instead unwrapping the operator with unwrapping the optional with the panic operator, and then calling change. So we can, yeah, I did it again. Let's change the name to OBO special. I don't know. For account 2, send it. Oh, apparently this profile doesn't exist. That's pretty interesting. Is that true? Let's see. That is true. There's no profile set right now. So let's go back. Let's set a test profile, OBO 7, account 2. Think that worked? Yeah, it did work. Okay. So now let's go ahead and can I clear this somehow? God, the old playground was so much better. Shame. Okay, so anyways, if we go to what is it? Here, let's change the name to OBO special. And if we send it, then we should see in the script that the name was changed. And we do. So the name was changed from OBO to OBO special. Hooray! Woo! Nice. So does anyone have any questions? I know I'm going so fast, and I'm basically trying to teach the whole language in an hour. So trust me, if you are a beginner to this and feeling lost, I don't blame you at all. You should feel lost because it's a lot going on. Um, so when you have a reference type, you should be able to call functions on it, right? Because essentially a reference type is just saying like it's the actual value of what's stored in there, right? Like it's not a copy like here, because this returns a copy. So when we have a reference type, you should be able to call functions on it to change its values and stuff like that. What we're doing here. And remember what I was saying, this is super dangerous right now, right? Because anyone would be able to call this public function and get a reference to it. That's not good. Okay, so we basically just covered everything outside of like, or maybe not everything, but we covered a lot of stuff. We're now going to get into, for the last 20 minutes, we're going to get into account storage resources, which are probably the most important. So we can add some rules to what can be accessed by others in a reference. Yes, you can. You can do that. And that's with interfaces, which I'm going to get to in a second. Okay. So what I'm going to do is just comment out, and we're going to talk about resources now. So a resource is very, very similar to a struct in that they actually look identical. The only difference is that a resource is defined like this. So instead of pub struct profile, it's pub resource profile. Looks the exact same. The only difference is how they are handled and like basically like managed. Profiles are a lot stricter. And they also unlock a lot of cool features that structs don't. So the deal with resources is that they're special where they can only ever so you can't overwrite them. So like with a struct, you can just overwrite it. You can't overwrite resources. They can only exist in one place at a time. When you move them around, you have to explicitly tell the language you're moving it. Sounds weird. And have to when they get destroyed, you have to explicitly tell the language you're destroying them to. So there's a lot of like extra stuff that's needed when you're dealing with resources. That's to make them more secure. And you can start to begin to think that NFTs and token vaults and all those like sort of assets that are like digital assets, those are all resources on the Flow blockchain or in Cadence. So step one is that a profile. I'm just gonna write some things here. With a struct, it's just profile, right? That's the type. With a resource, it's at profile. Okay, so this is how you represent a resource type. You have to put the at in what is yeah, just the at symbol. What is this called? Called the at symbol. um, yeah, you have to put the at symbol in front of the type. Okay, so you would think you actually put it like this. However, it's weird. In dictionaries, you actually have to put the at outside of the type. So you do it like that, okay? So this is saying we have a dictionary that holds resources inside of it. That's why we're putting this little at here, okay? Um, and another thing is now that we're dealing with resources, you can't use equals anymore. You have to use what's called the move operator. So we're moving this this resource type into this um, variable. So if we're dealing with one resource or a dictionary of resources or even an array, if we were to have an array of resources like this, you have to use the move operator. Okay, so let's go ahead now and let's add a profile, or let's figure out how to add. So another difference between structs and resources is that unlike structs, which can be created anywhere, they can be created outside the contract, in the contract, in a script, in a transaction, anywhere. Resources can only ever be created inside the contract. So this isn't even possible. So we're gonna change add profile to something like create profile. And what you do is you say let new profile. Um, you have to use actually I'll use the equals just so I can show you the mistake. Um, equals create. You have to use the create keyword with resources in order to create it. Profile. Okay. Now, in order to pass in we have to pass in all these things. So we're actually just going to add them as arguments to this function, like that. Okay, and so we have to pass them here. So name. This is the same as structs. Address, save number. But look at this. So this is saying equals. Uh-oh. Incorrect transfer. We expected the move operator. So yes, this has to be the move operator. We're moving a resource type into variable. But then look at this error too. It's saying, wait a minute, loss of resource. So Cadence won't even let us make this code because it's basically telling you that this resource is going to be left alone and lost, right? Because if someone calls this function, this resource isn't being stored anywhere. So this is just an example of how Cadence is so strict when it comes to resources, and it helps a lot when you're dealing with like digital assets, right? It doesn't let you lose the type. So we have to move this new profile into this dictionary now. So what we can say is just self.profiles at address, and we can move in the new profile. Now, there's another trick here, and it's saying, wait a minute, uh-oh, this is a problem because what happens if, there's already like, a profile at that address, right? What if there already exists a profile? Then what's going to happen is this new profile is going to overwrite that existing one, and that's not good. So there's two ways to handle this. You can either say, okay, we want to force move it in, right? And this is my favorite on the whole language. This is my favorite operator called the force move operator because it looks just so cool. You move and then you put the force operator. And what this is saying is, listen, if nothing exists at that key, then move it in, okay? But if something does exist at that key, then panic and abort the program and don't do anything, right? So that's what this is saying. And now it's good, right? So now Cadence is happy. There's actually another way to handle this though, and that's this is called like the double move operator. So we're getting into weird territory. But now we're gonna say let old profile, and we're gonna double move and then destroy the old profile. So what this is saying now is if something does exist already, it out into the old profile variable and then move the new profile in. And then now we can deal with the old profile however we want. But again, now that we have the old profile out, it's saying loss of resource because we have to deal with this now. So what we can do is we can maybe just destroy it and say, you know what? We provide the destroy keyword with resources, and this will just destroy the resource, right? Um, when I am dealing with resources, I like to, and dictionaries, I like to use the forest move operator. I think it makes the most sense. But if there are cases where you want to deal with existing cases, then you have to use the double move operator instead. Okay, so that is creating a profile. So this will add a resource to this dictionary. Cool. So we're gonna pause. Any questions on that? And we only have like 10 minutes left, and I still have to cover account storage kind of quick. But just gonna pause for any questions. Now, some of you may be asking, well, Jacob, I don't understand the difference between structs and resources. It sounds like resources are annoying. The idea is that structs should only ever be used for like basically like containers of data. So if you just want to represent data in a contained format, you use structs. For any sort of digital asset or entity or object, you always want to be using resources. OBO says, so I'm guessing if you want users to have multiple profiles, you need to make the mapping from address to yes, exactly. Um, exactly. But if you're a good Cadence developer, the answer is no, because you're going to use account storage instead. Ideally, you should never really be storing data like this at the contract level. You're instead going to store it in users' accounts, which I'm going to get to in a second. Okay. So issue, and I'm going to move this up just so that we don't have to keep scrolling. Okay. So the thing now is that so what we haven't talked about is account storage, and I'm glad that OBO just made that question. So in Cadence, the main idea is that users have control over their own storage, right? And so because of that, accounts in Cadence have their own storage where you can put resources and be able to access them at different times. So what we're going to do is instead of storing profiles at the contract level, where the contract owner is going to have to pay for storage. This dictionary could get really big, right? Like if we have like millions of profiles, this is going to become a super heavy, um, variable, and potentially we're going to run into a lot of problems with like just runtime inefficiencies and trying to access just really heavy data. We're going to move storage out of the contract, so we're not going to store it in here actually anymore at all. And what we're going to do instead is we're going to allow the user to create the profile, and then we're going to return their profile back to them like this. Okay. So we're going to return profile back to user. So this is a public function that anyone can call that allows them to basically create their own profile resource. And so we no longer even need to set this anymore. Let's go ahead and see what this is like. So we deploy this contract. Now all we've said is this is what a profile looks like, and anyone can create one, okay? So fair enough. So let's go to a transaction, and let's do that. So let's just say, and I think I probably have to refresh the page. Let's say let my profile, and we're gonna remember we've used operator, and we're gonna say test.create. God, why is it not? Let's go back, refresh the page. Create profile. Boom. Right? So what we can do is we can pass in the name. The address is self.signer address. We're going to change this to be more secure in a second, so don't worry. And favorite number. Okay. And then we're going to do something interesting. So we actually, okay, pause. So in order to access the account storage of an account, we have to have the auth account type. Now, this is where the prepare stage comes in helpful. So the execute stage is only for like performing like generic actions in a transaction. The prepare phase is for dealing with the user's account storage. So what we have to do is we're actually going to move this into the prepare stage instead. And now what we can do is say signer dot save. So signer is the auth account, right? It's the person who signed the transaction. And just for the record, you can only ever get the auth account in the prepare stage of a transaction like this, because otherwise it'd be extremely dangerous, right? So signer dot save, the value, which is my profile, we're going to move that into the user storage. And then two, this is where we provide a storage path. So the way the storage works on Flow is that there's different paths where you can. The best way I can explain that is, let's say that you have, let's say this is a user storage, right? The way that it works is there's a bunch of different just paths inside storage that all have a different place. So let's say this is like slash storage slash, right? This is slash storage slash one, right? So each of these little storage slots is basically like a container that just has a different path, right? So we're just inserting data into a certain path, right? Um, and you can create as many paths as you want, so there's not like a set number. So in this case, we're gonna store it to slash storage slash my profile, my test profile. Okay. So now after this transaction is over, this should exist in the user's account. We're gonna go ahead, and the name is going to be OBO. The favorite number is going to be 7. And we're going to send this from account, let's just say account 2. And it's done. No errors. So now it should exist inside the user's account. So what we should do now is we should find a way to make this publicly available to all of to basically, like, people that want to read my profile, right? Like, now that it's in my storage, what can I do with it, right? Um, so let's talk about that for a second. So now this is in my account storage. I need to give the public a way to read my data, right? Because it's not being stored at the contract anymore. It's now in my account. So how do I do that? Well, what you can do is you can say signer.link, and this is by the way, this is like, we're getting into like probably like the most complicated aspect of Cadence. So for the last like 5 to 10 minutes, I'm gonna go over by 5 minutes. I'm not gonna be able to explain everything, so I just apologize up front. I'm just gonna kind of speed run this. If you want to look more into this, I really recommend you check out the Cadence by example thing I sent. Again, like, I'm not gonna be able to explain this right now, but this is a really helpful link for capabilities, which we're now talking about. Um, yeah, and also account storage too. So I would read both of these. Okay, but essentially what needs to happen is we need to create a capability, and the reason for that is because we want to take our private storage data and we want to make it publicly accessible to people. So the way we do that is you can provide a public link, let's say my test profile, and we're going to provide a storage link, which is the place that we stored it in. And what this is going to do is basically say, okay, we're taking whatever's in that storage path, which we save the profile to, and we're going to make it accessible to the public. Now we have to provide a type here, and the type we're just going to say is test.profile reference. Okay, so when this gets run, this is basically saying that the profile that's stored at this path is going to be publicly accessible. Okay, so we already stored something there, so I actually should just redeploy the contract just to read the thing. And so we're going to store this again. So we're going to say the name is OBO and the favorite number is 7. Why that failed? But we're going to try a different account. Let's say OBO is now account 4. Testing purpose. Okay, so it's saved now. So it's now in account 4. So okay, so now this is available to the public, so we can actually now read it. Okay, so if we go into a script, we can now try to read someone's profile based on their address. Let's try that now, and we're going to return a reference to a desktop profile. Okay. So the way we do this is we can say um let profile equals get account address, Now what this does is it gets a public account, and we can actually we can separate this into steps. We can say public account equals get account address. Okay, and what this does is it gets a public account type. So that's the type of this variable right now. It's a public account. Now on a public account, you can get a capability. So let's say let profile capability public account dot get capability, and it's asking for the path. Now the path is what we provided here. It's the public path that we set when we made that available to everybody. So we provide the path. We also provide the type, and the type was again what we linked right here. So we linked a test.profile type. Okay, so we can provide that right here. So now we have a capability type. So the type of this should be a capability, where the type is a test.profile reference. And then lastly, we can say let profile reference equals profile capability dot borrow. And what that's going to do is basically take the capability, which is saying, hey, this is a pointer to the user's profile, and we're going to borrow it, which is essentially just saying, you know what, we want to actually get the underlying type in that capability, which is the test.profile. And then we can return profile reference. We actually don't even need to force that wrap because it's optional. So if we input the address here, which is account 4, should execute, and we can now see we're actually looking at OBO's profile inside of his account. Right, so I'm sure that your head is probably spinning in a million different directions, but that's the idea. That is how to publicly access this thing. Um, Now there's a problem, and the problem is that when we linked that to the public, we linked the whole type. We linked test.profile. So what this means is, while we did get this in a script and you can't change any data in a script, we could do this in a transaction as well. I could run a transaction that publicly gets OBO's profile, and I can get a reference to it. And then once I get a reference to it, I can now call change name. So I'll be able to basically change OBO's name because OBO has linked his profile to the public. So what we can do is use resource interfaces. So let's make an interface called profile public, and we're going to include everything in here that should only be public, which should just be the variables. So we're not going to include the function like this. Not going to include the function because we don't want the public to be able to call this. So we're only going to call these 3. We're only going to include these 3. And we can implement the profile public on the profile resource, just include these things, right? So now there's 2 different types we can have. We can have a profile straight up, which will have access to everything, or a profile that's restricted to the profile public, and then that will be the restricted type. So let's go ahead and redeploy this. And the idea here is that now when OBO goes to link the profile to the public, we can restrict it test.profile public. And now, if someone, I think I have to redeploy again. Hold on. Now, if someone goes to link this, so let's say, I don't know, let's come up with someone else. So let's just say, let's say OXstruct. And OXstruct, what's your favorite number if you're still listening? Maybe I'll do BZ instead. BZ, what's your favorite? Oh, 5. Perfect. Awesome. OXstruct, favorite number is 5. Awesome. We send it. I don't even, wait, what account did we just use? Oh, we used 1. Okay, so OXstruct's account is 1. We can go into a script now and look, if we try to borrow, if we try to do like or if we yeah, so if we try to borrow this type now, it's actually not going to let us, right? It says nil because we're borrowing the wrong type here. The actual type that exists is a test.profile public. So now this borrow should work. However, we can no longer call dot we can no longer call change name because look, member of restricted type is not accessible, change name. So we can no longer call the change name function on the profile reference because it's restricted. But we can still access stuff like the name, right? Because that is fully available on that type. Okay, so let's say the whole point of the script was just to get the name. Here's a string, and we get to say profile ref dot name. Okay, and if we type in OX01 here, we should get. Oh, I don't know why we're getting nil. I don't know if I have time to debug. I don't know why that's happening, but you get the idea. Okay. Um, so to go way back, and I know we're out of time, so I'm gonna have to stop now. But to go way back to OBO, your original question, um, how do we make sure that the address is not falsified? Well, the idea is that we actually wouldn't even provide the address anymore, so we don't even need the address. And the idea is that now we just identify the person's profile because it's stored inside of their account. So if it's stored inside of their account, we know it's their profile, right? And I can't store profiles for you because I don't have the ability to save resources to your storage. So we know that if a profile exists in your account storage, then it was saved by you, and thus it is your account. Yeah. Okay. Um. Yeah. Sure. Let me do that for all of you. So hold on. We no longer need the address, so let's get rid of that. Let's get rid of that. Create profile. Um. Yeah. Interfaces are awesome. For me, it's very intuitive how it works. I think for Cadence 1.0 banter, I think they actually are changing interfaces a little bit, which is super frustrating, but that won't happen for like 6 months to a year. Let me deliver. Let me send it. Okay, be good now. This isn't gonna work anymore. Yeah, a ton of this isn't gonna work anymore. I'm just gonna leave it because it might be helpful for all of you. So there is the playground link. All right. I hope that was helpful for all of you. Again, I basically like sped run through the entire language, so probably not that easy to learn everything. But again, I know I've said this 100 times, but if you're looking for a really easy way to learn basically everything I just talked about, check this out, the Cadence by example. All right. So I'm gonna end the YouTube stream there. So if you're watching this on YouTube, thanks for tuning in, and